if it's streaming. Today I'm gonna work on the poker tool that I was working before. I was gonna translate the code into Python from Rust, but then I opened the project and I realized that I lost the code. I think there's still a chance that I have it on the external hard drive, but it doesn't matter anyway because I was gonna do it in Python anyway. So I'm gonna have to do it from the beginning again. And I remember it was really hard, the first part, the part until the point that I finished the last time, which was to just figure out the cycle in the string and then capture the information and put everything on an object. And I remember that I had to think a lot because it's hard to think about the way you're gonna maintain the integrity of information, let's say, with the sequence of bets. That's the main thing that is gonna be hard, I think, is keeping track of the sequence of bets in each hand and then figuring out how to put each hand. I think I'm gonna put it on a CSV to only after that figure out how to communicate with Python, with PioSolver, which is a poker software. So I expect that it's gonna be really hard in the beginning. And since I don't have the code, I'm gonna have to do everything again, so it's probably gonna take a lot of time to do this. Expect that it's probably gonna take me several different days, but I think it's worth doing it because it's something interesting, and I kill two birds with one stone because I play poker and I wanna improve. So if I build this tool, it's gonna help me. If I can make it like the way that I'm picturing, then it's gonna help me a lot with poker, I think, as well. And maybe I can turn this into a software or a website or something and then sell in the future as well. So I think it's just a good thing to do it. That's why I decided. And in the previous 2 days, I reviewed a bunch of articles and then passed to the blog. And then I also finished doing the privacy policy page and the other pages that are more required for Google, I think, to treat you like a business or to treat you more seriously, let's say. They're crawlers to treat you more seriously. So I ended up doing that. And now I think I'm gonna work on this tool and spend 1.5 hours here today. I think I'm gonna go back and forth between working on this tool and working on Web3 stuff, studying Web3 and things like that. I'll put my music here and so I have to think now. They're probably gonna have one file for the cards for structuring the game, build a class, and then another one to read the hand history and parse the information. I should think if there's any other. It's been a long time since I don't do anything like coding. That's another thing why it's probably good to do this, because if I just write blogs, then even though I'm learning, I'm not practicing. So building something is also better because then forces you to think. As far as I remember, I can do this. I forgot how to specify if it's gonna be written or to read or the mode. Yeah, mode. Just read. And there's also the parsing that I can peak is F8, I think, encoding. I think the encoding is F8. Let's see. And I have to remember how to... I think, as far as I remember, is I used CSF writer, but that's for writing stuff. Don't remember how to read the lines in the file. Ah, there we go. The thing is, I don't think it's that much harder to build things in Rust after thinking about it. It is that obviously harder because then you have to keep track of the memory management and the pointers and stuff like that. That makes it a lot harder. But I think the main advantage of doing it with Python is that I'm already used to using Python more, and I think it's easier to look information about the Python libraries as well. There's a lot more stuff out there. But with Rust is because and the main point of doing with Rust before is that it was just to practice Rust, and yeah. So now this is the part where it gets complicated, because now I remember that like what I'm gonna have to do is figure out here where to put the limits, and then put a bunch of if else statements, and then structure the information. And that's the hard part. And the annoying part is gonna be the regex as well. So I remember this, I was using this one, I think, to determine when the hand starts. It's better to put the whole thing. I'm gonna take a picture of this as well, so I remember the sequence. I don't remember this. The difficult part about this, and the reason why I have to think a lot now in the beginning, is because I have to think about how I'm gonna try to communicate with Pio, because I don't know if it's possible just through the Pio API to node lock simulations. Or maybe I should show Pio solver here and explain for people that don't know. But pretty much the way that I'm thinking about this is getting the information and then getting all this data. And the other challenge is that I'm gonna have to reduce the level of abstraction, let's say, because if I put each hand on the simulation, then it's gonna take too much time to build all of the simulations, I think. So I'm gonna have to figure out a way to reduce, like, to simplify the bet sizes and the hands as well. So figure out a way to get the hands by frequency. So for example, which flop happens the most often, and which bet sizes happen the most often. So I can just create simulations based on that, on the hands that happen the most often. So that, because otherwise it takes a lot of time to build the simulations and to run them. So it's gonna be too long if I get each particular hand and create a simulation of each, which makes things a lot harder as well. So what I'm trying to do is to get the hands and then to communicate with Pio to build the simulations. And after building the simulations, then run them and then no lock them based on the data that I get here, which is putting my opponent's strategy on file solver. And I want to do this all autonomously, obviously, because I don't want, otherwise it defeats the point. But that's the problem, because I don't know if just with the API is gonna allow me to do that. To build the simulations and then put my opponent's strategy on the simulation, so I can see what would the solution be against the opponents based on the sample size that I have here. And then I can use that to train myself to play optimally against them based on the data that I have. There's like combining best of both worlds. But then the hard part is that how do you structure, with that in mind, how do I structure the information here so that it's easy to pass it there? And should I put the information on a CSV or not? Or like what should I do? I think the easiest is probably to put on the CSV and then later on use the CSV to, after when it gets to the point where I'm gonna communicate with Pile, then then I think about it. So I'm gonna do the same way that I did it the last time. I'm gonna make checks here based on the patterns, and then at each line I get the information. But I have to, like, maybe I do everything on a CSV and then I structure the CSV based on the hands, all the information that I have in my hand. So each column is a piece of information, let's say, that I want to get from the hand. So I put all the streets, let's say, but then the problem with that is that, like, the amount of bets can be arbitrary. So that's why I'm not sure if it's probably not the best way, because I don't know. Let's say, for example, that I bet and they raise and then I re-raise. Like, there's an infinite amount of ways that the amount of bets can go. So putting them each on a column, I don't think it works. I think the best way to think about it is to think about a hand, and then I try to go building blocks of hands, let's say, and then for each block I put the information that I have here. And who bets what and things like that. Yeah, but the way Pile Solver works is a poker software that allows you to run simulations. Now, pretty much what I think they do under the hood, they run probably a machine learning algorithm that defines the Nash equilibrium based on the information you put here. And then you can put simulations here. I had a bunch of this, but then since I deleted everything on the computer in the past, I had to I ended up losing, I think. I might still have it on the external hard drive, but I don't remember really well. But this is the simulations that come with file solver, I think. And then you can put the bats here. Then you can build the tree and run, and it's gonna solve it. Obviously, you wouldn't do like this because I'm just doing one bat size, which that makes it find a different Nash equilibrium that is not the best. And then once you run, then you can go into the browser, and then it's gonna show like what is the GTO strategy for you and for your opponent. And then what you can do is, based on this strategy, you can no lock. You can simulate like if my opponent didn't raise as much as Pio did, or if he raised more, then what I will do. So they put their opponent's strategy, and then you lock it, and then you run it again to solve it again, to play against that strategy. It has been a long time since I don't use this, so because nowadays it's pretty much like automatic already. I spend a bunch of time studying this stuff, and I'm not putting more. I'm focusing more on software developing, so let me run this again. It still doesn't work. And it's very difficult because the game is extremely complex, and then if you change one thing on one street, then it's gonna change all of the other ones, and that's what makes it so hard to study. Because let's say if you assume that the opponent's gonna bet more, then they check, then it's gonna change all of the other actions on all of the other streets. It becomes really hard to figure out what's the best way to play. Yeah, now it works. And not at all about you. Yeah, but now it's only showing the. Now that's two opposing thoughts, and yet both of them are true. Yeah, so it has to be like this. How can you experience everything you choose to do while observing the experience? It still doesn't show. From a higher view? See, it's the question. It's player, not players. Otherwise, you couldn't differentiate between the two. Awareness, but of who? You think you hurt me, but I promise I was letting you. They say we're all one, but where have we been heading to? I'd rather die free than have to live inside a petting zoo. I am the journey that I'm getting to. I think I'm gonna put with this, because then I can use the other string to catch the other patterns here. I'm trying to think if there's a way to make it like, if there's a better way to do it than the way that I did it in the past. The way that I did it was by getting the information here, then after each loop, after each hand, I could put a pattern here to the mark to know when it's going to be the end of a hand and the beginning of another hand, and then you do it in cycles, and then after each iteration, after each hand, that you put the information on an object, and you append that object to a list. Then you clean that object again, you reinitialize all the values, and then you collect for the next hand. So the way that I thought about it is kind of like creating a loop, where each cycle of the loop is a hand, and then you extract the information, put that on an array. And then from that array I would put that information on a CSV, and then use that information to communicate with Pyro, I think. That was the plan. I'm trying to think if there's a better way to do it here. That is gonna be easier. Because maybe I don't need to separate by hands. I can just get all of the information. I need to get a picture with all of the hands as well. Like all of the streets to the river.
It's not the human race.
And I think it's gonna be until number 3 maximum.
To chase. We do not run this place. But both medicine and poison's an acquired taste. So I started taking selfies of somebody else's face.
Simply the children of this world.
I think that the best way is that way. I can't think about it in anything else. Because the challenge is that the amount of actions are going to change for each hand. So if I try to keep them separate, like just create an array for each part of the hand, then the indexes are going to be messed up. So the only way is to put all the information for a hand. Maybe I can create a class called hand, and then I put all the information that I would need in the class. And then at the beginning of each iteration I create the class, and then Yep, and then what is the boundary? That's the... I think I need to get more lines. And so I think the way that I'm gonna try to do it is create a class for each hand, maybe. I can create a class for each hand and I make it accept the players. Yeah, it goes up to number 4. thinking if I create a class, if I can build it with using the asterisk to unpack the players. And then I'm thinking how I would make it equal, each player equal to something, if I do it like that. I can create a loop, I think. I'm not sure if that's the best way. I think general is not the best. I think I use players on the last one. Should mark when is the start of a hand, and the start and end of a hand.
Je crois que je poursuis un rêve impossible. Je pense que ça marchera pas, mais j'y ai cru quand même. Je nous revois, je revois tes yeux, je revois ta bouche, je revois tes cheveux, ton visage. Et je me demande si toi aussi t'y penses. Je me demande si toi
Problem
aussi
is,
tu me
if I
revois
create a
quand tu
class, I
fermes
think
les
it's gonna
yeux,
be
quand
too
tu
complicated in the end.
C'est un rêve
'cause
impossible.
I'm gonna have
Tu
to
m'avais
extract the
donné
information
tout ce
for
que
each
t'avais à
one.
faire, c'est de me dire de rester.
But maybe
Mais
I
t'es
can
parti.
do
Et t'es
maybe I can
revenu.
do a class of player and then put a bat.
Et puis t'es revenu.
Put class and bats, initialize
Encore et
bats as an
encore.
array.
Et à chaque fois c'est la même chose.
It would have to be an object, I think, bats, so I can keep track of the rounds. So each key is a round and the value is the amount of the bat. And if checks is 0.
Tout ce que tu avais à faire, c'est de me dire de rester. Et je serais restée pour toujours.
Yeah, bat's 0.
Toujours avec toi. Alors pourquoi t'es parti? Pourquoi tu m'as laissé? Ça va nous échapper entre les doigts. et on
Oh, I
jouera de toute
remember
façon.
that this was a
Ça va
tricky thing to
s'arrêter.
figure out as well, which is the position of the players. Because here, there are no positions. So I remember spending a bunch of time thinking about that. I think that's the first one is the small blind, and then the second one is the big blind because of the actions here. And then it was hard to figure out the other ones because then you have to subtract based on if-else conditions. And the thing that I'm concerned about is that because I can't use match, it's gonna get really big, the code. I'm thinking about using a class called player. And then this is gonna take, I think, position, bets. And the problem is that I can't really use position because, or maybe I can just, I can cache the position for the next iteration of the loop, I think. Yeah, that's the way that I was doing. And it was tricky in Rust because then I had to deal with the whole memory and pointers. Meaning Python is gonna be handled for me, so I think I can just reinitialize. But I can, because the problem here is that at the beginning of each hand, I'm not gonna know, like I'm gonna have the information about the players, but I'm not gonna have the information of what's their position until we get to the rounds here. And I think it starts off with small blind and big blind, and then the first to act is gonna be small blind on the round number 1, which is the post flop. Yeah, so I think I have to do it based on this shoe here to figure out the position, because it looks like it shows like all the players, even though not all of them are in the hand. It looks player 3 has 1.3. It doesn't show cards. Don't understand. Oh no, that's it still has the cards of everyone. And so I think that this is the pre-flop. That's the thing. Yeah, so here is just dealing the blind, the small blind, big blind, and then here is pre-flop. So the under the gun is gonna be the first one to act. So in this case would be number 3, and then it goes until you get through. And the tricky part is that because sometimes you can have less players, so but then you can just make it based on the sum, like the positions. So number 3 is gonna be under the gun, then number 4 middle pair, middle position, and then cut off, and then bottom, and then small blind. Yeah, but that's the tricky thing, because if there's less players, then the positions are gonna be different. So, and I forgot how I did that. But I know it's kind of hard to figure out. Because I have to subtract, obviously, the amount of players, so I can keep counting on pre-flop. And this is gonna be really difficult, like I said before, because I remember doing this and there's all of these things that are hard to figure out. That's why I was thinking that there must be an easier way, or maybe there is an easier way to do this instead of doing cycles like this. Like if I could, instead of worrying about the cycles, if I could just extract the information without thinking about that, and then after I figure out, I think that would be better. The way that hopefully I think is done. So the way that it works now, you just put strategy and EV, and then it shows you like this is the auto position, this situation, big blind versus button, and then you check, and then you can see the strategy that would be optimal to play. And if you bet here, forgot how you do this. also compare actions. My set strategy, unlock node. Yeah, that's how you do it, I think. So here you can go and you can place whatever strategy that you think your opponent will play. And this is different than before. I'm selecting range explorer. I remember there's a way to decrease just one of the cards, but I don't remember how. You can select, I think it's just selecting here, yeah. The problem is not changing here, it's supposed to change. Oh, there we go. It's still not working. I don't remember how to do this. I think if I do it with the older version, I'm gonna remember this one. Yeah, this one I remember, I think. Yeah, so now you can go here, I think. And then put check 7 here. And then it changes the... Yeah, this one I remember. I think it's because I didn't use the new one enough. Yeah, but now you just call 100% and then put lock all hands. So this would change their strategy from raising Jack 7 to just calling 100% of the time. And then let me do some like extreme where they never raise, so that is clear. Then you can solve again and then you can see what would happen, like what would be the best strategy. Like something like this. And you can see that now it's betting like this amount. And I node lock there. So you can go here, you can build again, I think. Don't remember really well. I think you just solve it. I don't remember. I have to watch videos or look into the documentation to remember how to use this. But I know that you node lock there and then you solve again, I think. Or you build again and solve it. And then it's gonna figure out what's the best strategy. And that's what I want to automate here. Based on the data that I have. I think I should try to think about a way to not do the cycles because I think it's gonna be easier. I think the best, if I could just get line by line based on the parameters here and then create something based on that, I think that would be better. It would be a lot easier to do, I think. So maybe I can test it out, just creating the different columns for CSV for each player, and then for each street. And the problem is the whole action thing, the amount of bats for each street. Maybe we can put putting on a. Yeah, I think that's the key point that I have to think about. Is how to translate the actions so that I keep the integrity of the sequence of actions. And can do that with this actual number here. If I can do it. And the problem is if I put everything on a CSV and I just make these different colors than columns, then the actions are going to be messed up, I think. Because there's not going to be a way to know, or maybe not. Because obviously it's always going to start with 0 and then 1, or action number 1. So maybe it doesn't matter. I should know each hand as long as I have all the actions for each round. Yeah, but then the size of them are going to be different. That's the thing. The size for each hand, because some hands are going to have more actions and some less. So and then later on it's going to be hard to reconstruct, I think, based on that. I think it's worth typing stuff, because then like it's kind of a there's no way, like I can't skip the thinking part. I just need to think what's the best way first, I think. I think I want to try to do it different than I did last time, because I think that there might be an easier way to do it. There's something that I'm missing, I think. Because I remember the whole cycle thing with the hands is like, it doesn't feel like it's the right way to do it, I think, or the best way to do it. So I'm thinking about if maybe there's another data structure or another way that I can hold the information without depending on the cycle of the thing. Maybe I can use a heap or like a tree. Yeah, maybe that's a good idea. I should probably do that actually, because it is a game tree, so yeah, obviously. My problem is how to store the information, that's the thing. Because I can create a tree and then put the information, but then how I'm gonna store it later. I still think that the only way is gonna be a CSV. But I think using a tree is probably better. I'll have to remember how to do it. there's value and then neighbors. And the thing is, there's also several different ways to do it, because each player is like a tree, and then each action is like a tree as well. I can also think about each round being like the main tree, and then from each round there's another tree connected to it based on each player. I remember I did something with Scarlet Draw to clarify this thing, and it was very complicated. Because there's the rounds, and the players. Each player is gonna have multiple different actions for each hand, and then each round has multiple different actions as well. And everything is obviously connected. And here you should put cards as well. So cards, bats. Or maybe I don't put it here. Create a function to append the bats to this thing. Or maybe here is better to do names as well, or to do name. And then cards, that would be I can empty string first, and then I update later. And the most challenging part is thinking about this, like the data structure that I'm gonna use, and how to keep the information, so like how to structure the information so that is the easiest way possible to extract everything, and then to put this information on to store the information on a way that I can use it later to communicate with file. Because I think it's better if you structure the information first, and then use that information to communicate and to structure and communicate at the same time. Because obviously then you would have to parse everything all the time, but if you parse everything once and then you use that to, then you can build a lot more things with the parsed information that are not necessarily, like maybe in the future I realize that I can't really do what I want to do here, which is automate the node locking process. But then because I have the structured data, I can do something else, like, and I think that's a lot better. So I have to think about a way to structure the information, what kind of data structure to use to structure this information, and then what is the best way to store that data structure. Maybe I should try to create a graph first to see how it will look like. And I can make it so, because the way that I'm thinking about it is creating more, like creating the players once, let's say. Because obviously it's gonna be different players, but if I do it like this, then it's gonna be easier, and it's gonna be like an archetype where the player one, but then it's really, but it is in a sense what I'm trying to do, because even though the player one is gonna change all the time, it's like I'm getting the archetype of the pool of players that I'm playing against. So player one is a bunch of different players, but because I'm playing against the whole pool, it's kind of like the bet sizes are gonna be an approximation of what everyone's gonna do. So I don't need to separate each hand. So maybe it's better if I do create each player one time in the beginning, and then I just like put all the information for each player on the class, and then I use that information kind of like a tree structure, or each player is at the top. But then how do I relate that to the cards as well? Because I would have to, so there's two separate things, one is the players and then the other one is the streets, I think. But that gets really confusing, because the streets would be repeated all the time. So I think that the information has to be on the player, probably, of the streets, and yeah, but the problem is the position as well, so I can't really do that, because each time each player is going to have a different position. Unless I do it by position. Instead of doing a class of players, I do a class of position. And so here, for example, I think it worked. Yeah, so now I can see that this strategy is locked, but here is betting a lot more than before, because they never raise. And then this changes the whole game after. That's why it's so hard to think about it. What can I do here? I think there's no other way, actually. Now the more I think about it, like I have to separate, because of the whole problem is the information. of the sequence of bats for each hand. That's the problem. But the issue is, if I create a class for each, I think that's still a problem, because then how I'm gonna store the information later. And that should be an object, not a list. Or maybe this should be a number. Yeah, this should be a number, the other should be a string. So I'm thinking about now of constructing each player for each round. Just do from 0 to 6, choose all the players possible. I'm doing the same way that I did before, because I can think about. But then the only difference is that I use the tree to keep track of the information about each player. So I have the hands and the stack in the beginning here, and the cards. And then for storing the bats, then I can use the tree maybe. So, but then, like, what is the point of having neighbors? Trying to think if there's a way to encapsulate in the same tree the Heaver, the cards, and the bats. Or if that's gonna get confusing. You can think about each level of the tree as being the round. And the problem is that I don't think that it would be good to mix the cards of each round with the bats. And if I link the actions, then it's not really a tree, it's just a linked list of each action to the other one. Maybe you can ask ChatGPT, see if it's gonna give me like some insight. I'm thinking in my mind about creating a graph first, and I'm trying to think about the best way to structure the graph. It's just hard to, it seems easy, but it's hard to think about, like, what is the best way to do it. And I don't want to start just writing the same stuff that I did before without thinking, because it might save me a lot of time. But I also think it's a good exercise to think about, because normally I wouldn't use a data structure because I'm not used to doing that. So I think that it is probably better to try to incorporate a tree data structure, and then I force myself to think about the different algorithms that I'm gonna have to create to navigate the trees and get the information. I think that's a good, but I'm struggling to come up with something that, like, a good way to structure the information that is gonna allow me to capture all the hands and store the hands later. That's the difficult part. The thing about the tree, I think, is the best because obviously it's a game tree, but the difficult part is figuring out, because each hand's gonna have a flop, or may not have a flop, or other cards on the board, and then each player is gonna have multiple bats, and then obviously the common thing between them is the bats. So the player have bats and the bats have boards, let's say, or the boards have bats as well. So that you could create that link, but then how do you put everything? Then you can create another class to put the hand. But then, like, the problem is that later, after, if I do everything on classes, then I put those classes inside of a list. I think it's gonna be really hard to, because then the problem, I still have the problem of unpacking all the information in the class to put it on the CSV or something like that. So I think it doesn't solve the issue. I think it's more something fundamental that I'm missing, of like how to structure the data so that is the easiest possible to save the data to use it later. Because I think just creating this structure is not going to allow me to save it later to use it. think I'm not missing anything. Yeah. I think after I stop streaming, I'm gonna spend a lot of time thinking, best way to structure. I think once I have a good idea in my mind, then it's gonna be a lot easier to just code everything. Because the challenge here is that how do you transform this into the CSV later? Like you either have to create multiple different CSVs, which is not good, or it's still the same problem because how I'm gonna capture. Maybe the best way is not to put it on a CSV, choose something else. Because ideally, what I would have is the information for each hand, like kind of in boxes. And then I extract that information, because then it becomes really easy to communicate with file, because you can just extract each hand and then build the simulation from that. Actually, what I'm trying to do is not even that, because the thing is I'm not going to do the simulation for each hand. Yeah, that's the thing that I'm not thinking about, because the point is to get all of the hands and then create an archetype. I think that's the thing. Because it's not even possible to put like just a single hand here. I have to put the whole range, which is all the possibilities of hands that they're going to have for each position. So what I want to do actually is create, like, based on all of the data of what people play, then create the range based on that. This is the stuff that I think I need to think more, because I'm thinking about the whole thing, about creating the whole, but maybe I should separate into like smaller problems that like, instead of trying to create a simulation in the beginning, I just try to create the range. I create something that creates the range, and then I can incorporate in multiple different files, I think. And maybe that's a better way to think. Because I'm thinking more on a script kind of mindset, I think. Because it's the stuff that I'm used to doing. Which is just to create a script, and then the script solves the problem. But for something like this, like, I need to think more in a software engineering way about the software design. So I break down the problem in several different parts, and then I build each different part based on a subset of a problem. And then in the end, I create something that connects all the parts together based on the logic and the flow of information. I think what I need to do is figure out first how to create a range based on the data that I have there. I think this is better. And that becomes a much easier thing to do. But what I'm trying to avoid is to create a bunch of different CSVs from the data that I have, because then it becomes memory. It doesn't become efficient with memory. Because then for the same hand, I would have multiple different CSVs, which would create too much data, I think, and it wouldn't be good. So I'm thinking maybe I should start with file and trying to communicate with file first to see what I can do. I think that's probably the best thing. But I'm thinking now more about not doing what I'm doing now, which is like try to solve everything. I'm thinking more about making something that is gonna allow me to get all the hands in the preflop. It should be a lot easier. Yeah, the other challenging thing is the stack size. Yeah, but I think I should think like that instead of worrying of each hand, I extract, like I try to construct one hand based on like all of the values. That's the thing. But the problem with that is that it becomes complicated because of the stack size in the board. But I think I'm gonna switch the problem. I'm gonna think about how to construct the ranges first. That's, I think, a probably better way to think. So I'm gonna get information for each position. So then the problem switches in my mind, where it's not about getting transforming all the data. It's just getting the information for this and then building the range first. Yeah, I think that's... And then I don't need to store the data because I can just store the range itself based on the... And then if I want different ranges, what I can do is change the data. I think that's a better way of thinking about it. So the only thing that I have to figure out now is the positions here, which becomes a lot easier to do. Maybe I can build a class, but I think maybe classes are not necessary. Yeah, I need the position and the cards for each player. So maybe position. And the name wouldn't be necessary. Let me see. So the cards are only gonna show up on the round 1, I think, for players. But then I need the round 0 for the positions. Obviously I would do like this, and then just change the if statement. That's the easy part. You can just put here. And then obviously do the same thing here. I think a leaf is probably better because it's not gonna run the two, like it goes line by line, so it doesn't matter that it only runs one condition. So here I put the logic to, and maybe I should separate into functions. That's one thing. I can create the class in the beginning, and then I can create a method in the class that the thing is, do I need the... I need the names, so I think... But maybe I can get the name from the action as well. Oh, that's another thing I have to think about. I don't remember exactly how I did this. I think I did it with a flag variable. Yeah, I can create a round here. Or actually here in the beginning of the hand. Maybe I put 0, but because I need a logic to determine which action I'm gonna get each. So based on the, maybe I'm thinking about a flag variable, and then based on that I get, because the actions are always the same, the line. And I can get by number as well. But I need to get by round, because then it's easier to get the position. But what I'm trying to do now is to to get the positions of each player for each round here, and based on the positions I get their cards and then I put on this class, and then because I'm trying to abstract get from all of the hands I have here, all of the hands that were played and went to showdown for the position. Is that way? Then I think it's not gonna be possible to fully reconstruct the range, because obviously a lot of the times it doesn't go to showdown, so you can see. But I think maybe the hands I have here show the cards anyway. Oh no, it doesn't. It just shows XX. So what I would do, so I have to separate by rounds, and then for each round, because I want to get the position. So I know that round number 0 is going to give me a small blind and big blind, and then for round number 1 I have to subtract the amount of players that I have here. And maybe that's the way that I did last time. Like you get all the players that I have here, the amount of players, and then you subtract from this two, and then you get the other positions based on the round number 1. And then based on that, I get the cards if they... Yeah, I get the cards and the position. So I need the name, the cards, position. For each round, but then the thing I wouldn't need to do it like this. I wanna just build once the class and then put the information for all of the hands without having to parse. But I think I need to parse because I need to do the whole loop thing because of the way the actions are here to get the position of each player. But I think after getting the position, then like I should probably initialize outside of the loop here. So I put, yeah, so instead of putting name here, I would put just position. And then I initialize here, like big blinds, position. I forgot how to paste. I think it's Ctrl D. Yeah. EP is earlier position, so it's the one after the big blind. And this is what I'm gonna do, I think. So I initialize each position in the beginning, and then I don't, like I create the logic to know which player is at each position. And then I put their cards. Yeah, that's all I need. So cards is gonna be an array, and then I can create a method here to get cards, or yeah, maybe get cards is good. Then self.cards, .appends card. And then inside the logic here, I'm gonna get which what the position of each player, and then just append to each one of the classes depending on what the position is. I can create the methods and then pass the hands. And then instead of thinking about solving the whole thing at once in only one file, I break down the problem into several different small problems, and then I'm probably gonna create multiple different files. To each one is gonna solve like one part of the hand, I think. Yeah, I think that's much better. And then the thing that's the reason why I think I can do it this way now, and that I didn't do it this way in the past, is because this way the downside is that I'm gonna create only the archetype. So it's more like thinking about how to create a single hand for, or an archetype of player from all of the hands. And then based on that player, then create the rest of the hand, which is going to be unique because obviously each hand has different bats and different cards. But that's my concern here, is that it might not be possible, because I think that actually creating the range makes a lot of sense to do it like this, but the rest might not be possible to separate because you need to do hand by hand. But I think no, actually, because I can separate the board and the hands, the board and the bats. So I can do another file where I have the hands, where I have the board cards, and then from the board cards I have the bats, and I create a tree structure of each round of the thing is gonna be one node, one level of the tree. So it starts off pre-flop, and then level 1 you have the flop, level 2 you have the turn, and level 3 you have the river. And there's one more level because you have, the way that this file is structured, you have the other round that is just posting the blinds. But then I can do it like that, and then each level of the tree is gonna have the bats. Yeah, but the problem is that I would still need to associate that bat with a player. But maybe it's not necessary, because as long as I have the position of each player, I can determine. Yeah, but then, like, I think that's the part that's confusing to me the most. It's like how to associate because when I think about it, it's very intuitive. Like when I'm thinking about here, it's just, you can simulate multiple different players, or you can, but it's not perfect because multiple different players not solved. There's no Nash equilibrium. So you can only do 2 players at a time. So each time that I'm doing these simulations, I'm thinking about the specific positions. Like, for example, player big blind versus button. But then the challenge is obviously if you're dealing with the data, there are like, because you have both the boards, the cards on the boards, and then the positions of the player and the bet sizes. So how do you connect all of these 3 different things using a data structure, or maybe multiple different data structures, in a way that is going to allow me that is going to be easy to manipulate later, once I figure out what I can do with the API from Pile. That's the challenge, I think. It's very confusing, because if I create the tree, like I said before, with the boards as levels and the bats as the nodes, the leaves, then the issue is that I don't know, I can't think about how to put the position of the player on that tree. Because the player would have to be a node as well. It would have to be connected. So either you create 2 different trees, but then I wonder if that's the best way, because you can create you can create a player. So instead of having you have the node as the player. You have 2 different types of nodes: the player node and the player node and the bets node. Or in the levels node, let's say. Or you can just create the tree where the levels are, and then each player has the information. That's probably the best way. So the player has the bats, and it has the position, and then the player is a node on the thing. But that doesn't make sense. I think about that later. I think I have to focus on this one first. But that's what I think I'm gonna do. So in this one, I'm trying to construct the range based on the position here. So the ones that I need are round 0 and round 1, and this one is gonna start. And then here, I think I have to put... Yeah, that's the thing. I remember that I had to create 2 different players here because it's... The challenge is that it only goes line by line, so... But I really think that there must be a way to filter the whole file without going through the loop. I think, yeah, probably using regex. That's what I'm trying to do. But then the issue with that is the whole thing about the position. That's the biggest problem. Okay, here there is no information about the position of the player. Only the button. So I think the only way to get the position is to go through the loops. And then if I go through the loops, I go line by line. So I need a bigger condition, I think, to determine. So I need to put like if line not find layers. That means that is the beginning of a hand. And then inside of this, I put this thing here. Because then when it hits this, then I have a flag variable here. Maybe beginning. And equals 1. But if I put here... Yeah, then I had another one, I think, to determine the end of the hand. Equals 0. So when it hits here, but then it should be the other way around, maybe. So I need a flag variable that keeps track when the hand starts and when it finishes, and because it's gonna go line by line, so there's no way to... Yeah, but this doesn't work because it goes line by line. That's the thing. So it would go outside here, this one. And this is if beginning was 1. Hands started. So when it hits this point, then the hand started, and then I got the information here of the names of the players. But then that's the thing, because the end can't be this thing here. So maybe it's the other way around. But then it doesn't work anyway. That should be something in the end of the hand, I think. Like this game session. But I remember I used players, I think, on the previous one, if I remember correctly. Maybe I'll go watch my own video to remember what I did. Yeah, but what I'm gonna do now is figure out how to... For each loop, I'm gonna get the position of each player. And then I'm gonna use this class to get the cards for each position. So I initialize each thing here, and then depending on what the position of the player is, then I get their cards, and then I append to the cards here. And then at the end, each one of these is gonna have all of the cards that were played for the whole data set, all the positions for all the data sets. And then with that, I'm gonna be able to construct roughly a range for each player in the beginning for each position. Then once I have that range, then I can think about the other parts of the problem, which I think I'm gonna create different files to deal with. But I'm also thinking that that's probably better, or might be better, to try to build something simple to communicate with Pio first, to see what kinds of things I can do and how I'm gonna need to structure the information in the end, because that's gonna help me obviously think about what is gonna be the best way to structure the data structure, so that I can go from the data that I have here to using the Pio API to build the simulations. But yeah, I'm not sure. I think I'm gonna probably finish this one and then I think about it. I have to think a lot more about it. About how the most challenging part is the one of creating the hands, creating the bat sizes for each hand, and then creating the cards. That's the most challenging thing. Because there's the three things that I talked about: the player, the board, and the bats. And thinking about what's the best data structure to use to put them all together, with having in mind that I'm gonna build the simulation later. The thing I'm trying to think about is how can I, because what I want to do is, like, because I'm getting the range for each position based on all of the data, in the way that I'm gonna do here, then what's gonna happen is, like, I want to imagine as if the whole data set is just one player in each position playing. But then the question is, how do I determine the hands, like the actions of each hand? That's the problem. I guess I can separate by position also, because each position then, but I think I'm gonna do it on another file based off the data again. But then because there's probably a way to, I probably gonna do a class for a position again, and then instead of having this information here, I'm gonna have two different trees. One is the cards of the board, and the other is the bat sequences. I think what I have to do actually is separate the bat sequence thing in its own file. That way I can create a data structure that keeps track of the bats, which is probably going to be a tree. And because the challenging thing, like, that's the challenge, I think, creating an algorithm that, regardless of how many bats there are for each hand, it constructs the line that the hand will be. Because I think in terms of lines when I'm thinking about it here. So for example, check would be a line, and then check bat would be a different line. And that's what's hard, because each hand is going to have an arbitrary number of actions. So because I can't really know, because I'm evaluating the whole data set, then it's like, how do I construct an algorithm that is gonna get the actions and then is gonna give me the line so I can build the simulation later, so I can node lock the thing. So maybe I should separate it in two different parts. One part, the first one that I'm doing here, is I build the range and then I build the initial bats. And for myself, obviously I'm gonna lock different bat sizes because I want to simplify the game. So when I build the simulation, I'm gonna put the hero, which is myself, in the dataset with fixed bat sizes, and then for the bat sizes of the opponent, I'm gonna use the size of the data. So that's the thing. I think I don't need to think about. Yeah, I don't need to think about the. That's the thing that I'm missing here. I knew I was missing something, but now it makes a lot more sense because to build the simulation, I don't need to think about the boards. I can just think about the bat sequences, and then I think about the boards later. That's the thing, because I can just get all the data for the boards and build the simulations based on the bat sizes that I have on here. It's actually a lot easier. But the thing is, that's the problem, because how I'm gonna node lock the... Because that will give me the size of the whole tree for each bat that they do. Oh, I'm gonna node lock based on the cards. That's how I do it. So for each line that they take, like for each card that they have, I can compare that frequency, the frequency on the data. It's gonna be very hard actually, but I think it's a very interesting thing to do, so I'm gonna try to do it. But I'm not sure if I'm gonna be able to do it because it's gonna be really hard. But what I'm thinking about is comparing the... Like I build the simulation, then run the simulation, then the simulation is just gonna be a bunch of numbers in a matrix, which is this thing here. And then each cell is gonna represent a frequency, and then based on this frequency, like based on the sample size, I can see, like, but then the reason why it gets really hard is because I would have to keep track of the frequency. But yeah, it's actually not that hard. I think I can just create a counter on Python, and the counter is gonna be a dictionary that keeps track of frequency based on keys. And then for each, I can create a matrix based on the game, based on the same way that it is here. And then I can create an algorithm that creates the frequencies of this matrix. And then based on that, I compare this matrix from the solution from the matrix that is created from the data that I have. But I think there's definitely a better way to do it than the way that I was thinking before, because the way that I was thinking, I think is not the... I was thinking about solving the whole thing, but I'm missing this other stuff, which is the way that you build the simulation here is gonna differentiate the information that I wanna have at each point. So it's like, instead of trying to parse the whole information and structure the whole information to create the hands later, it's much better to parse the information in different ways, and then for each specific thing build the small thing, and then only after recreate the stuff that I want to do. Deconstruct everything. Yeah, so I think the best way is probably to make a matrix like this, and maybe create the deck here. The thing is, I'm not sure if it would be better to leave on the same file that I create the game itself. Obviously it would be something like this, where you have the... And now I don't know. Because I'm gonna have to reconstruct based on the whole diamonds, hearts, that kind of stuff. But I don't know why I was thinking about the dictionary. It should be that hard to create the game. Maybe I can find online or can use ChatGPT to create the class that creates only the cards of the game. And then obviously on this class I would put the strength of each hand as well. Like what does it mean to have a flush? But I think that part is gonna be very easy to find online probably. That's why I'm not worrying about it. But then what I can do I think is create the matrix, this matrix here. And then think about it in terms of matrix where I'm changing the frequency and the data of the matrices based on the data. And so I'm gonna stop here. I'm probably gonna continue to do this tomorrow. But I'll think a lot more about this off stream. And I might do a lot of stuff off stream as well. But it's gonna be, I expect that it's gonna be very hard and it's gonna take a lot of time to do it. But hopefully I'm able to finish this. Not sure what's gonna happen obviously, but yeah. And I might go back and forth. I'm probably gonna go back and forth into doing this and doing blockchain stuff. Yeah. But probably tomorrow I'll continue to do this, so